I want to express my thanks in the beginning for all the other cooperation of the SAIL Work Package C team, especially Lucio, Lucia. Lucia is here, and Lucien, our project manager or the work package leader here, and Olivier, because they did present or prepare some of the slides which I am presenting here, which are Slishi also presenting later. Yeah, I have the nice pleasure to introduce you to OCONS. And the question, of course, what is this? And do we need it? Where is it from? Does it not have any use? Maybe to answer these questions, we have to go back a bit to what Benoit presented yesterday. What is SAIL? SAIL is having 3 technical work packages. And they have exciting names like Network of Information. So this is the idea of getting rid of real addressing and just address the information directly with the name of the information, not bothering where it is located, and trying to form a new network paradigm out of it. We have the idea of cloud networking and virtualization. We had some presentations yesterday on that already. And then the question is, what else do we need in SAIL? I mean, we have something really exciting topics, and we have the idea, well, also both of them have networking in the name. We need something else below, and that is something construct an open connectivity service. That's our initial idea here. And that is what OCONS should do. So we're trying to present or create better connectivity service than we have today, which somehow should support the other exciting research topics of SAIL. So the motivation for OCONS is already mentioned a bit. So how can we move to something which is better in means of connectivity? And then we had questions in the beginning, what should we do? Should we do something completely new? We tried that in Forward. We had generic paths and a very abstract model. But, well, in the end, the internet is not as bad as we might think, so why not try to maintain the best and gradually improve? And so in the end, we were trying to find an open framework for improving the connectivity for today's application, future application, and also in particular the cloud networking and the the information-centric networking. This is, of course, not that easy. It's a big animal somehow. So we have to think about how can we do it. And I'm trying to give you the basic ideas, and then we go into some more research topics afterwards with Lishi and try to reflect it back to the other parts of SAIL with Ramon at the end. So the outline is, I will start with an outline, I will have the main part, and will conclude with a conclusion. Not really. We will have also some kind of the mechanisms which we have in the scenario. We go to the architecture, and then we will look into how can we make up, how can we create OCONS connectivity services. Also discussed yesterday a bit, we have a SAIL scenario where we think about what is in a scenario which is challenging and which we can use to reflect what we are doing at. And then the scenario is basically, well, there's something exciting happening, like a summer school in a location where you never think about. Everyone is trying to show it's Facebook, into Facebook, what is being seen, and the networks are not made for it. So we have a lot of new or unexpected number of users somewhere. It's unplanned, and we have to create the connectivity and the services for it. So we have ideas. We could move some of the processing of the data centers closer to the users. We can find good connectivity to the servers, to the transcoding devices which we might need in the network. And then, of course, as SAIL is a project with more than 25 partners, everyone has some special expertise. So we have a lot of expertise and a lot of ideas what we can improve. And, of course, you have to start with some nice research and then put it together to big picture. So what we can do is, of course, just think about where can we change something. We can think about, and that is what Susanna is doing later today, we can think about if we have a delayed terror network, a disconnected network, how can we forward and route there? Can we do there something better? And then we can think about, yeah, if we have something like mobile users, can we optimize the resource management? If we have 2 different access options, Can we somehow use multipath? Can we use several connectivity at the same time? How do we balance? How do we select? Do we duplicate the packets on two interfaces? Do we split the flow? Do we use one flow here, one flow there? What is best? What is best from the user point of view? What's best from the network point of view? What's the best for the overall connectivity? So we can think about also, if the user is mobile, how can we improve the mobility management? So how do we have the best signaling that we have a seamless handover, that packets arriving here know where to go, where the user is. And well, so on and so forth. So I think we have something like 15, 16 different groups working in different areas. And the question is, how can we make this again to an open service? How can we do better connectivity with lots of small improvements? And that's what I had before. Oops, sorry. What we said before, we try to maintain the best and gradually improve. So we could we have a number of good and excellent ideas where we can do better, and now we have to put it into a framework. Any ideas how to do it? Well, that was the problem we started with 1.5 years or 2 years ago, and we found some architecture. By the way, if you have questions because you don't understand me, I'm talking too fast or anything, just interrupt, and we'll have a discussion after lunch break. But questions for things which are not understandable, just ask them directly. So it should be more summer school lecture type than a presentation. Okay, so that is the scenario, the context we are in, and now we try to think about how can we improve, how can we make service out of it, and how can we move to a connectivity in the future where we can reuse synergies as well. Not inventing the wheel every time. So what we started with is trying to think about an architecture and think about commonalities. And the easiest thing is you can say, okay, in any service, in any mechanism we are doing, you have 3 different things. One thing is you somehow collect information. It could be network state, it can be policies, it can be on the contract of the users, and we define entities which are just there for collecting the information. Then we have other entities which just decide. They take the information, the policy, the rule, or the network state information, and do the decision. And it doesn't matter at the moment if that is a multipath connectivity service, if that is a handover mechanism, or if that is something like a DTN routing scheme. And then once you have decided, you need someone to do it. So you need someone as a working horse, the enforcement entity. So with this, you can describe existing mechanisms as well as future mechanisms. And the idea we have is that in the future, you could think about a nice decision algorithm which you can implement on an entity, and you can reuse it for different mechanisms. So if you know with some kind of a prediction mechanism, with some kind of neural network type, to investigate different signal strengths, you could do this for handover as well as for multipath as well for something else. So it's reuse as much as possible because you broke down the architecture to some kind of atomic entities. And then based on these atomic entities, we can make mechanisms. So we try to think about the next level of hierarchy is we have mechanisms, and this could be made of, or this is consists of one or several decision elements, 1, 0, or multiple information elements, and execution or enforcement entities. Maybe just take an example, because that's getting very abstract. I hope we get more to the facts later today. So if you have a mobile terminal, in a very easy case, we have 2 different access technologies. So we can think about the mobile terminal has something like an information element, collecting the signal strengths, for example. We have a decision element, deciding which network to take. And we have an execution element, which is enforcing the handover, or enforcing the usage of a network. So then we have the access elements, and for example, there might have information element also collecting information about the network state, about the usage of the service. It could be also the network congestion behind the access point, which is here available in the information element. And we might also have execution elements which help in doing the handover in associating to this access technology. And then we have the second access technology also having the information and the execution elements. So the process would work basically, we have a connectivity request from an application, and we select what you want to take. So the first one, we receive it. In the second step, the decision element takes the information from all the information elements, and then decides what to do. And in the third step here, the selection of the network is being executed. And you can think about, of course, that this you can do with many, many algorithms and mechanisms. You can describe it with these simple elements. And the nice thing is, if you are collecting signal strengths here, you could use that for a number of different mechanisms in the end. So there's a potential to reuse these things, but of course we have to think about signaling protocols here and how to orchestrate, how to organize it. If you think about our architecture further, we have something like our users. So what's the user of a service? Well, we have an application, of course, but we also say the clone and the network of information might be users of our connectivity services. Then the service itself, we can think about service on different layers as well, or on different levels. They are basically invoked by a request to do something, to communicate something, and we compose them of one or multiple mechanisms. So it could be an access selection, can be a flow control, a congestion control mechanism, which you all combine together to a service. So these mechanisms which you use to compose a service have to interact, and some of them you have to select because they might complement each other, so you can have several of them, but they might also be, in the selection process, they might also be conflicting, so you can only have one of them. So you compose a service of mechanisms, and the process of composing we call orchestration. So that's the functionality which selects the appropriate mechanisms, and just in order to provide the service. Then the next part which we need to describe in architecture is the node, and we call an OCONS node any node which has OCONS capabilities, which means it has probably some entities and maybe an orchestration functionality included. It also needs some kind of an OCONS ID which enables the communication and interfacing with other nodes, with other OCONS nodes. Of course, we also have to make sure that our architecture, which also would be able to use and accept and communicate to legacy technology and mechanisms. I'm sorry, it's getting a bit abstract, but please try to stay with me one or two more slides that you get an overall idea of it. The next things which we have is something, yes, we have some kind of orchestration service access point, which is an interface to the OCONS users. So that's where you can specify requirements and requests for a service. This can be something like, I want to have a certain quality of service. It can be also just be, I want a cheap and fast service, or I just take best effort. So this could be a policy ID or some profile ID. It can also be an explicit request of what you need. It can also be that there's no explicit request and that we implicitly try to figure out what the user might want. Okay, if we want to orchestrate our service, we need to know what is there. And therefore, we have a registry, where all OCONS entities, mechanisms, and launch OCONS services are registered. And that is where we can look up how to make up the service. This is itself inside, or it's related to an information element. Then, if we look for how do we orchestrate, we call it an orchestration process because it's not an own entity, it's not an own device. It can be composed also of IEs, Ds, and Es if you want. And this is responsible for bootstrapping, so we have to set up the network somehow. We have to respond to a connectivity request. And also, if something changes in the network, we have to respond to it. And we also have to monitor if everything's all right. If something is going wrong, we can change our orchestration. We can activate a different mechanism. For example, if one network fails, you have to think about which network to take as an alternative. So let's go a bit into these different things which we discussed. So starting with the orchestration process. With the bootstrapping. Somebody was bootstrapping here. Bootstrapping. So the first question is, how do we discover and register OCONS entities? and that's the first step. Then they need to be somehow validated, certified, that we can registered in the register. And then we have to think about how to compose a set of default open services. So it's some kind of basic network support without considering any application, just that we are able to communicate and also exchange signaling information. You have these things in your USB stick, so I'm not going into much details here. In any case, this is much too small. We have it that you have it as well. We have the different entities here. They register with the register, and then we can use it for the service orchestration. But if you want to look it up after this lecture, you can check it directly on your USB stick. I will mainly be talking to the slides because that is explaining the pictures. So the second question which we have here is how do we respond to connectivity request? Or what happens if the network is changing? So the user might be moving, you have different network state information, you might have a congestion like our flash crowd scenario. How can we respond to it? So on one side, we have to think about, we have to know what the user wants. And this is basically our orchestration service access point, which we have. That's it's something like a socket, an evolved socket of the application where it can signal what it wants. It can also be that the network information which we have is changing, which we have from the monitoring, which might be a collection of information elements. And then once we know that something is changing, that we have a new request coming in, we have to select the mechanism which can support it best. So, well, now we have two bad network connectivities. Shall we then go to activate a multipath, that we do use two at the same time? Do we do a different flow management because of that? So we would select the mechanism based on the network conditions, the scenarios, and the user behavior. And then, based taking a number of mechanisms together, we have a service composed, and we can provide this to the user in the end. So this also means we have to allocate the resources and configure the mechanisms appropriately, and then we have started, or we start the service, and then the user can in the end use it. That's the idea which we have here. Also, again, you can see it in a bit on the slide, on the graph. You have the user, you have the service orchestration process here, and it basically selects or checks the register, and then gets the information here from the information element, and then invokes the mechanisms. Also, once the service is activated and running, we have to monitor it. Some entity has to monitor that the service is working as expected. And that is what we call monitoring the service. And therefore, we use monitoring capabilities. For example, network state, which is on some of the information elements. It could be on the node, in the link, in the interface, and so on. And it is typically unrelated to specific user requests. So it's just knowing what is on the network. And if something changes, we may have to reconfigure the open service accordingly. So this sounds quite abstract, and there's a lot of work which is still ongoing. So what we are doing now at the moment is for each mechanism, we are trying to, we are expressing the capabilities to some kind of information model. This is also giving something like how is the mechanism, how should it be built, what is needed, what's the requirements, what kind of ISDs and Es it does it need, when does it work nice and when does it work optimum, and so on. But this can be very simple. It can be just we can classify it as a network selection mechanism, so it would be a certain class and could have just a quality identifier like 7. And once you need something which selects a network, you would take the one which uses either least number of resources or has the highest quality identifier. We have to think about how to select the mechanisms. This can be, in the end, also very complex. You can think about nice scientific topics here. You can think about auction-based, game theory-based mechanisms to select, but you can also think about simple rules. Like I always take the only one which is available. I take the one which is first, or which has taking the least resources. But of course, I'm trying somehow to map it to the application requests and so on. If you then think about how to aggregate the service, we are still working on the composition. So we know that which mechanisms are selected, what the network condition is, but still there's some work ongoing. And then we have, of course, also, and we have answered some of the question already, that we need some kind of IDs if you want to communicate between the different mechanisms. If you want to identify, well, then we also need an own identifier. We need some kind of lifetime, we need an owner, and we might need the requirements here as well. And then also the data which we use for monitoring of the services. It could be operation metrics, it can be connectivity requirement assessment, and so on. These also need to be expressed in some kind of a data model. So we have, that's the next slide already. So we need to know how we can express and put in a semantic correct form the user demand profiles. This could be just a number, yeah, and the number has some kind of specification behind. We have to think about how can we, what's the user demand profile, what does it mean in some kind of OCONS connectivity requirements. That's something which we can understand. So maybe the demand profile is just a number, then we have to relate it down to something which our orchestration process understands. We have to think about how to, or we have thought about how the network state can be described. And we have this mechanism capability description I just mentioned before. And we need the rules for mapping the demand profile into the connectivity requirements, for mapping the connectivity requirements into the network state, and for mapping the connectivity requirements then and the network state and the candidate mechanisms into the service composition. So these rules can be, I mentioned that before, can be very, very complex. So you can do a lot of PhDs and master's theses here, but you can also just hardwire it. Yeah? So you always take the first available, or you only take the one you try to map between the requirements, the capabilities, and take the one which has the best quality identifier, if you can find something simple there. I think this is basically what I mentioned before. So this mapping, again, determining the connectivity requirements. You basically have the orchestration process. You have this orchestration access point or service access point. You have the demand profile, and you, in the end, as an output, you have the connectivity requirements. So this can be, a request can be, I have a traffic profile. It could be just a number. It could be something like 1 megabyte every 20 milliseconds, for example. It can be some kind of required quality of service. I need at least 1 megabit, a maximum delay, a maximum packet error rate, or I just need something best effort. I just want connectivity and I don't want to pay anything. We might have a requirement that I need seamless mobility, or I just say I have video streaming, please do the best I can. So this we have to map. This is a request which we might have. We have to map to connectivity requirements. So the next step then is how do we determine what we need for it? How can we compose a service? What kind of mechanisms are candidate mechanisms we could use? And we have to know what these mechanisms can do. So we have to think about where is it working? Is it on flow, on network, or on link level? What does it do? So we have to classify it. So we are preparing classes here. So this is the name and the class. We have to think about what's the characteristic. What does it do? What is the target? So these needs to be put into a semantic way which a machine can understand. We have to think about what are the requirements, what are the constraints, what can it guarantee, how can it be configured, and what does it depend on? So what does it need as in means of information elements, execution elements, and so on. And then once we have the rules for the service composition, the connectivity requirements, the candidate mechanisms, we can set up a service and provide the service to the user. And that's it. And now we go to what is next. So I know that this was quite abstract, but this opens you a very nice architecture and very nice framework to use new services, to invoke or to use as well existing mechanisms. So you can put the information about existing mechanisms like TCP flow control, like mobile IP version 4. You can put that as well into your orchestration register and reuse it. What we are doing next, Li Shi will present some of the selected mechanisms in much detail. This will be a bit more scientific. And then we also will see how these mechanisms and the orchestration can be used at the Flash crowd scenario for NetInf and clone. Okay, with this, I will close and let the real work for the next person.